All right, the last graph that we're going to investigate in Unit 4 is the tangent function. We'll touch very briefly on secant, cosecant, and cotangent if there's some time on our review day, but we are going to start looking at all these key features of tangent. So, how does tangent relate to the values on a unit circle? Well, we know that the tangent of theta is equal to the y value divided by the x value. We also could say that the tangent of theta is equal to the opposite over the adjacent. We also then could say that the tangent of theta is equal to the sine of theta divided by the cosine of theta. Well, in thinking about this then, we could take our sine graph and our cosine graph, and at every angle divide sine by cosine and get a value for tangent. But we can also use our tangent values that we already know on our labeled unit circle, because we already did that work. So in goes theta, out comes the tangent of theta. So if I look at my unit circle and I go to 0 radians, the tangent of 0 is 0. If I go to pi over 4, the tangent of pi over 4 is equal to 1. Tangent of pi over 2 is undefined. I'm just going to skip that for a second. Tangent of 3 pi over 4 is -1. Tangent of pi, 0, because 0 over 1 is 0. Tangent of 5 pi over 4 is 1. Probably label those. 3 pi over 2, undefined. I'm going to skip that for a second. Tangent of 7 pi over 4, we are back at -1. Tangent of 2 pi is 0. Well, also on here I've got negative pi over 4. Well, negative pi over 4 is just traveling backwards, pi over 4, which would really land me at the same coterminal at 7 pi over 4. So that's going to be at -1. And then backwards pi over 2 really means 3 pi over 2, undefined. All right, well, let's see what this says. Think about other angles on the unit circle, or use your calculator and plug in some other values for tangent to connect the points and complete the curve. Hint, you should have vertical asymptotes on the graph. Well, vertical asymptotes are going to happen whenever we have undefined values. So that means I have a vertical asymptote at pi over 2, negative pi over 2, 3 pi over 2. This is looking kind of weird. Well, it said to connect our values. If we connect other values between 0 and pi over 4, I know that at pi over 6, my tangent is the square root of 3 over 3. And at negative pi over 6, then I'd be at negative square root of 3 over 3. So that helps me connect a little bit. And I end up with these tangent waves that look kind of like a cubic graph. That should be a little bit more well-defined. Kind of like a cubic graph. They have a nice smooth curve to them because we are unwrapping the unit circle after all. And we know unwrapping the circle creates nice smooth graphs. But this time we have these vertical asymptotes because every time we would take the sine divided by the cosine, and the cosine was 0, we'd be dividing by 0, an undefined value gives us a vertical asymptote. Now the other thing to think about is as we move away from 0, our opposite side gets taller and our adjacent side gets smaller. So a bigger number divided by a smaller number leads us to these increasing values. The same thing would be true as I travel in the negative direction. My y values get negatively bigger while my x values are getting smaller. So I get a bigger negative number divided by a smaller value, creating a big negative number. All right, where is one complete cycle on the graph you created? Well, I'm going to say one complete cycle would be between asymptotes. So negative pi over 2 till pi over 2. I have graphed all of my values and gotten right back to where I started. So we're going to say from negative pi over 2 until pi over 2. We could write that in interval notation. Or we also could write it as an inequality. The domain and range of the arctan, that was the inverse thing. Well, the domain of arctan was negative infinity to infinity. And the range was from negative pi over 2 to pi over 2. Well, we know from inverses, if we invert things, we switch the x and y, which means we really switch the domain and the range. So now my domain for tangent is going to be from negative pi over 2 to pi over 2 for that wave that I looked at, and my range is going to be negative infinity to infinity. Now, this is just talking about one period, one cycle. The domain of a tangent function actually is kind of hard to write. We need to think about it's pi, right? I go from here to here. That's a total distance of pi. But I have to skip every asymptote. So to write the actual domain of tangent, it looks kind of funny. The domain of the full tangent is going to be negative pi over 2, because that's my asymptote, plus pi times n. Okay? We don't need to worry about that much for this course, but I want you to think about every pi, we end up with a new asymptote. When we started our asymptotes at negative pi over 2. All right, so let's talk about the tangent graph then as a parent. Well, we just said its domain is going to be negative pi over 2 plus pi times n, where n is an integer, so we can go forwards and backwards pi units and end up with those asymptotes. Our range is negative infinity to infinity. So we go from all the low values all the way up to the high values. Our period this time is only pi. That is different than our sine and cosine wave. And our amplitude, I'm actually going to say, is none. If you think back to the definition of amplitude, it's supposed to be half the distance of the range. Well, if my range is everything, how do I take half of everything? You can't. So we don't have an amplitude. We will instead have a vertical stretch, just like transformations, of A. But tangent does not have amplitude. No amplitude. Tangent, no amplitude. So one period of tangent, our parent function that we are going to work on transforming, has a starting asymptote at negative pi over 2. We have a key point at negative pi over 4, a key point at 0, a key point at pi over 4, and then another vertical asymptote at pi over 2. So I still have 4 intervals, 5 key points. It's just that they're only between negative pi over 2 and pi over 2. So vertical asymptote, crossing this middle point. It's not a midline because your midline would be the middle of the graph, and we're going to infinity, so there really is no middle. Okay, then negative pi over 4 would be negative 1, and positive pi over 4 will be at positive 1, and then I connect these through in a nice smooth curve. So again, 5 key features: vertical asymptote, vertical stretch in the negative direction, 0, vertical stretch in the positive direction, vertical asymptote. Okay, so the amplitude, none. But the A value will create a vertical stretch, just like transformations. It'll be a stretch if A is greater than 1, a shrink if A is less than 1. We will have a flip if A were to be less than 0. The period is just going to be pi divided by b, right? We're comparing to the parent function, and the parent function completed a rotation in pi. Our intervals then is going to be the period divided by 4, except this time we're going to count, well, I'll get back to that in a second. Hold on. Vertical shift will still be our d value. Horizontal shift will still be our c value. And the point that you're shifting when you do the horizontal shift the point that actually gets moved as our starting point, that gets the shift, is this one right here. And then we'll move things to the left or right depending on that blue dot, which means that when we count our intervals, instead of starting here and counting to the right 4 tick marks, you can do that. We'd end up here and this other point. We also need to count backwards. So we're going to go forward and back from C, and we'll see what that looks like when we practice graphing these. Our starting asymptote, this is something kind of new. Our starting asymptote is going to be, if we take negative pi over 2, oh, that's getting pretty intense. Let's see if I can change this to write a little better. Negative pi over 2, there we go. We're going to set that equal to our b times x minus c value. And that would allow us to figure out our starting asymptote. Now, the other way to get the starting asymptote is to go to your horizontal shift C and just count backwards 2 intervals, and we'll still get to that starting asymptote. So again, we'll practice both ways. The horizontal shift is going to move that blue dot. The starting asymptote, if you solve this equation, will be this pink vertical asymptote that is 2 away from the horizontal shift. So our strategies, same as always, find all key features, and then, features, I'm going to say plot C and count 2 intervals, 2 intervals to the left. That gets you your starting vertical asymptote. And to the right gets you your end of the period. Okay. Big things to remember. The period for this one is only pi. Pi, 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 not 2 pi. Okay? And we'll practice in the next video.